This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2019 AP Calculus exam, free response question AB2. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading in Kansas City. I'll present a brief general summary for student performance on this question. Then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where appropriate, I'll present some specific scoring examples. Now, just a reminder, this is a calculator active problem, so students may be required to use their calculator in some or all parts of this problem. In this question, the velocity of a particle p is given by a differentiable function v sub p. Selected values of v sub p of t are given in the table, and we know that particle p is at the origin at time t equals 0. In Part A, we need to justify why there must be at least one time t for t between 0.3 and 2.8, at which the acceleration of particle p is 0. In Part B, we are asked to use a trapezoidal sum to approximate the value of the definite integral from 0 to 2.8 of v sub p of t. In Part C, a second particle q moves along the x-axis with velocity given by v sub q. We need to find the time interval during which the velocity of the particle is at least 60 meters per hour. And we also need to find the distance traveled by particle q over this time interval. In Part D, we're given the position of particle q at time t equals 0. We need to use the information from Part B and the function v sub q to approximate the distance between the particles p and q at time t equal 2.8. Part A was worth 2 points. 1 point for conveying that the difference v sub p of 2.8 minus v sub p of 0.3 is equal to 0, and 1 point for presenting a justification using the mean value theorem. Note that there is an alternative solution on the scoring guidelines. This second common solution presented by students involves the extreme value theorem. Part B was worth 1 point, simply for the answer using a trapezoidal sum. Part C was worth 3 points. 1 point for presenting the correct interval, 1 point for writing a correct definite integral that can be used to find the distance traveled by particle q, and 1 point for the actual distance traveled by particle q. Part D was also worth 3 points. The first point was for writing a correct definite integral that can be used to find the distance traveled by particle q over the time interval 0 to 2.8. The second point was for finding the position of particle q at time t equal 2.8. And the third point was for the answer, the approximate distance apart. Here are some general comments about student performance on this question. In Part A, many students recognized the need to use the mean value theorem. However, some students made errors in communicating the hypothesis, or simply did not state the theorem hypothesis. Some students failed to present the relevant difference quotient. And of those students who did present a difference quotient, unfortunately, there were some arithmetic errors, and some presented the reciprocal of the correct quotient. And some students attempted to use the intermediate value theorem for justification. This is not a valid approach in this problem. In Part B, many students presented a correct trapezoidal approximation with sufficient work. However, there were some responses that lacked supporting work or with poor communication. And unfortunately, there were some arithmetic errors here also. Now, some students used the average of a left and a right Riemann sum approximation, which is a valid approach. And it seems like most students understood the concept of adding area in order to approximate the definite integral. But some had trouble using trapezoids, and that is, finding the area of a trapezoid. In Part C, most students did indeed present an appropriate interval with correct notation. However, some students listed only values for t, or points of intersection, or only one point of intersection. Many students understood the concept of distance traveled using a definite integral. However, there were some decimal presentation errors here, and some intermediate rounding errors. In Part D, many students presented a correct expression for the position of particle Q. However, there were several common errors. For example, no use of the initial condition, an incorrect value for the position, which could be linked to calculator usage, no value presented at all, or decimal presentation errors. And finally, most students did recognize the need to find the difference in the positions of particles P and Q. Just a couple of reminders as we look more carefully at the scoring guidelines. There are no units required in any part of this problem, so any units provided by the student are ignored. And because this is a calculator active problem, decimal presentation errors were possible. And because this problem involved a trigonometric function, degree errors were also possible. That is, errors in which the student solved this problem on their calculator in degree mode. There were three common student responses in Part A. The most common involved the mean value theorem, or Rolle's theorem, and I will focus on this solution. The second involved a local argument and the extreme value theorem. Now, I think this was a more difficult argument, but we scored this by following the scoring guidelines. And finally, some students attempted to use the intermediate value theorem. And this was not a valid approach here because we don't know enough about the function v sub p prime. The first point in Part A was for conveying that the difference v sub p of 2.8 minus v sub p of 0.3 is equal to 0. The general philosophy in awarding this point was, did the student sufficiently convey that v sub p of t is equal at t equal 0.3 and t equal 2.8? Here are some sample student responses and how each was scored. In examples 1 and 2, the student has certainly conveyed that v sub p of t is equal at t equal 0.3 and t equal 2.8. The first point is earned, and they are eligible for the second. In example 3, the student has conveyed that v sub p of t is equal at t equal 0.3 and t equal 2.8 by presenting the applicable mean value theorem quotient. So this earns the first point. Example 4 is pretty minimal, but also earns the first point. In example 5, the student earns the first point in words. In example 6, the student does not earn the first point. They must explicitly use the values of v sub p of 2.8 and v sub p of 0.3 from the table. And in example 7, the student does not earn the first point. The word function here is too ambiguous. The second point in Part A was earned for a correct justification using the mean value theorem. And there was an eligibility criteria here. The student must earn the first point. To earn the second point, the student response must explicitly declare that v sub p is continuous. But the student does not need to state that v sub p is differentiable. Now they may use Rolle's theorem instead, since the value of the function is the same at the endpoints of the interval. And they may relabel or misspell v sub p of t under the pressure of a high-stakes exam. For example, the student may state their justification using the function labeled as just v. Therefore, to earn the second point, the student must explicitly state that v sub p is continuous and connect v sub p prime of t to the first point. Here are some sample student responses and how each was scored. In example 1, the student has misspelled v sub p, but they have conveyed that v of t is equal at t equal 0.3 and t equal 2.8, stated that v is continuous, and stated the correct conclusion. So this response earns both points. Now, example 2 shows another misspelling, and it's pretty minimal, but it also earns both points. In example 3, the student has also misspelled v sub p, but sufficiently conveyed the equality. But they never said that f was continuous. So this earns 1-0 in Part A. The point in Part B was for the answer, and for sufficient evidence of a trapezoidal sum. To earn this point, the student must present the correct values, of course, and they must present evidence of a trapezoidal sum. Now, this consists of at least 3 products, at least 3 terms, and a sum. Now, the student can earn this point with an implied sum, that is, without any symbols. They could also find the average of a left and a right Riemann sum. And we won't worry about the symbols used here. Both of these are okay. Here are some examples of Part B responses and how each is scored. In example 1, there are 3 products, 3 terms, and a sum. This final numerical answer does not need to be simplified. This earns the point. In example 2, the student has not sufficiently conveyed a trapezoidal sum. This does not earn the point. And examples 3 and 4 are essentially bald answers. There is no evidence of any kind of a sum. Neither earns the point. In Part C, the first point was for explicitly stating the correct interval. The interval presented can be open or closed, and the interval may also be presented in exposition or in prose. If the interval is only evident as presented with a definite integral, then the first point is not earned. That is, we do not read the interval from the limits of integration. Here are some examples of responses associated with the first point and how each was scored. The first 3 examples all earn the first point. In example 4, the student has not presented an interval. Therefore, they do not earn the first point, but are still eligible for the second and third point. Similarly, in example 5, there is no interval presented. And in example 6, the student has made a decimal presentation error. They do not earn the first point, and they are inoculated or immunized against other decimal presentation errors in the problem. The second point in Part B was for presenting a definite integral that represents the distance traveled by particle q over the appropriate interval. Now the student earns this point for an integral in either one of these forms, for these values of t sub 0 and t sub 1. The function v sub q is positive over this interval, so the absolute value symbol is not necessary. If the student omits the dt, they may still earn the point. It depends upon our interpretation of the integrand, and there are a few examples below. Here are some examples of expression that earn this second point. And here are some examples of mishandling of the constant 60 given in the problem and or the dt. Here the student earns the second point for appropriate values of t sub 0 and t sub 1, of course, but is not eligible for the third. And in this expression, the integrand is wrong. The student does not earn the second point and is not eligible for the third. The third point in part C was for the distance traveled by particle q. We expect the student to use technology here, so this expression is sufficient to earn the second and the third point. However, a bald answer does not earn this point. We need to see the mathematical setup that leads to this answer. Here is an example of a decimal presentation error. The student does not earn the first point, but earns the second and third. In this example, the student has made a decimal presentation error in the interval. They do not earn the first point. They earn the second point for the definite integral, but the final answer is not correct, rounded or truncated. This error is probably due to intermediate rounding, so they do not earn the third point. The first point in part D was for presenting the definite integral of v sub q from t equals 0 to t equals 2.8. That is, for knowing that this definite integral was a necessary part of the expression for the position of particle q. Again, the absolute value is not necessary here, since v sub q is positive over this interval. Now here, the student must use v sub q with the correct limits. There is another velocity function at this point in the problem, so we need to see that the correct one is used. So therefore, using just a v of t does not earn the first point. And if the student omits dt in the integrand, they may still earn this point, depending on the interpretation of the definite integral. In this example, the student earns the first point and is eligible for the second and third. In this example, the dt is missing. The integrand is ambiguous. The student does not earn the first point, but is eligible for the second, but cannot earn the third point. The second point in part D was for presenting the position of particle q. Simply stated, this must be our answer. Here are some example responses and how each is scored. In example 1, the student has the correct definite integral and computed the position correctly. They earn the first 2 points and are eligible for the third. In example 2, there is a decimal presentation error. The student earns the first point, but not the second, but they are eligible for the third. The third point in part D was for the answer, a positive difference between the position of particles q and p. There was an eligibility criteria here. The student must earn the first point in part D. Now, there was a special exception to this rule in the case of a copy error. Any value may be imported from part B and used to compute this distance. And the difference may be implied, that is, no explicit subtraction is shown. Here are 2 more examples of part D responses and how each was scored. In example 1, we see the definite integral and the position of particle q explicitly stated. The student reminds us of the position of particle p, and let's assume this was found in part B, and the distance is given as an implied subtraction. This response earns all 3 points. In example 2, the definite integral is presented, but there is a decimal presentation error. The student earns the first point, but does not earn the second point. They have explicitly shown the subtraction and done this correctly, so this earns the third point. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. There is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.